All right, guys. So we're going to kind of tackle the power rule, which is a way to use instead of the limit definition. Remember, yesterday we talked about the limit definition as h approaches 0 of f of x plus h minus f of x all over h. So this here is pretty much slope. That's pretty much the slope at any given point. And we call this the limit definition of a derivative. Okay? A derivative. All right. So remember, when you see the word derivative, we're thinking slope. So reminders, derivatives are the slope of the tangent line at any point on the graph. So it doesn't matter. You go like this. You can find the slope here. You can find the slope here, here, any point. So in essence, we are finding the instantaneous slope at that exact point. Remember, it's that specific point. And there's many ways that we can write derivatives in math. So one of them is if you have like f of x, we call it f prime of x. So we call this f prime, which is the first derivative. Sometimes it's equal to y, and so then we call this y prime, and that's considered the first derivative. So there's ways to write these that are different all the time. Okay, so we have f prime, we have y prime, we also have dy over dx, which is the change in y with respect to x. How much does y change with respect to x? So we're talking about slope. And that is also considered the first derivative. You have multiple ways that you can write this. So the first derivative is either f prime of x. First derivative can be written as y prime. And the first derivative can be written as dy of dx. And so you're going to use all of these different terminologies. So just kind of get used to that whole piece. So as you guys tackle this, we end up today you're going to be using mostly the f prime x and y prime x. So when you see that little prime, that little apostrophe, that's just going to tell you that there's a derivative. So let's just talk about the power rule. So the power rule is a little rule that helps us deal with some things. So if we have f of x, let's just call it f of x of anything, it doesn't matter, to whatever power, and we'll call this coefficient a in front. So we have a, the coefficient in front, and any type of function, and then its power right here. Okay, so what we end up doing to get f prime, so now I'm on my first derivative, and we'll work our way to second derivatives. So if I'm working with my first derivative, I'm going to take n, and I'm going to times it by a. So my first derivative is n times a of whatever that function is, n minus 1. That's my rule. Multiply, then subtract 1 from the power. That's why it's called the power rule. We're using the power. We multiply the power to the coefficient, and then we subtract 1 off the power. It's always subtracting 1. And then whatever this piece is in here. Okay? So that's considered the power rule. There are some little tricks to the power rule that you need to kind of know. First, let's say the first trick is square root of x's. Anytime it's a root, you have to change it to its fractional exponent because we need the power. So we're going to use the power. So watch for fractions. That's the first trick. I'm looking at your guys' worksheet right now. Second trick is when you have something like this, you need to multiply it out right now. We have another shortcut that we'll learn later, but anything like this, you got to multiply it out to make it x squared minus 4x plus 4. So that way you can apply the power rule to each one. So don't forget the power rule gets applied to each one of these and keep track of your negatives. I'm going to go back to our roots here just to remind you guys. Third trick is when you have something like this. A couple of things. This is the bottom of the denominator, so this would be x to the 2/3, and then you can apply it from there. I'm looking here, looking. I don't see there's any tricks in here. No, nothing major. So there's only a few other little fourth trick, one more fourth ideas or fourth little trick. So when you get something, let's say like 2x to the -1, x cannot equal 0. Don't disregard this, but it really does. It just really means that this x value can't equal 0. So it's stating your domain for you. So there's a few problems like that that are stating the domain based on the graph itself. And then it may not ask you to find the derivative. Just remember, fifth trick is if they're asking you to find the slope, they're asking you to find the derivative. So when they say find the slope, make sure you find the derivative. And again, this one, tonight's worksheet 1 through 29, is all power rule. It's all power rule. And then number 30 is the limit definition. This is what you'll get once you get through the limit definition on Monday. You really only do it every once in a while. So don't forget the limit definition to find your f prime. And then the last thing is, and here's the last thing, and then I'll do a couple for you here. The last thing is no, there can be no exponents. Not exponents. Let me cross that. There can be no variables in the denominator. You have to move them. Denominator. And then no variables in the denominator. And then use, and I should say move fractions out to coefficients before you start. So what I mean by that is you can't have any variables in the denominator. So I'm going to start with that kind of idea first. So let's just start with, let's just say my f of x is equal to 2 over 3x cubed plus 2x squared minus 3x. Let's just say it's something like that. Okay, so I can do the power rule to these guys. That's not a problem. This guy poses a little bit of problem, so you're going to have to rewrite it before you find your f prime. So we're going to rewrite this as an equivalent. I'm going to take this x to the third, and I'm going to create a negative exponent and move it up. So it's going to become 2 thirds x to the negative 3 plus 2x squared minus 3x. Okay, now I'm going to take this fraction and I'm going to create a coefficient out front. So really what I get is 2 thirds times x to the negative 3 plus 2x squared minus 3x. And so I am going to find, off of that, I'm going to find my f prime. So my f prime of x is going to equal, we're going to multiply the power to the coefficient. So it's negative 3 times 1 times 2 over 3. And we're going to do x negative 3 minus 1 plus 2 times 2 x squared minus 1 minus 3 x to the first minus 1. Let's clean this thing up. My 3's cancel out, so I get negative 2 x to the negative 4th plus 4x minus 3, because x 1 minus 1 is 0, and x to the 0 power is 1. So that's my f prime. Now I can find any value I need. I can find any value. So I can find the value at slope at any x value now that I can plug into here. So I can find it at any x value. So that's kind of the idea behind the power rule. The only other one that kind of becomes an issue, you just got to watch out. Let's just kind of tackle f of x real quick equals square root of x, which is going to equal x to the 1/2. So when we do this one, I'm just going to do f prime right off the bat. We're going to multiply 1/2 times the front, so we get 1/2 x. So you're going to have to know some fraction rules. So we're going to get 1/2 minus 1. This usually right here poses us a little bit of a problem. So let's just tackle that a little differently. I'm going to go actually down here real quick. So let's slide this back up again. So I have 1/2, and then don't forget on fractions, you need a common denominator, minus 2 over 2. So then we get 1/2 x. 1 minus 2 is negative 1/2. Now, the answer may not be there. You may have to rearrange this. So the negative 1/2 makes this go to the bottom. So my actual answer in its fully simplified form is 1/2 root x on the bottom. Okay, so I'm trying to do a little bit of review with you guys. I'm not sure where you're going to be at. But that's kind of how you tackle everything. So everything, if you notice, has to have a power. So we got to get rid of all the roots. Everything has to be in like a linear form like this. Separate your fractions out like I did here. So I separated my fraction out. It was part of the problem to start over here, but I ended up separating it out so it's a coefficient, so it's easier to deal with. Those are basically all the little tricks. And don't forget at the end to plug in your value at any specific point. A good way to remember this is to say slope at point x, y, whichever that is equal to whatever your slope is that you find. Okay, that's a real good way to write it. So I will talk to you guys later. Good luck.